All right, I kind of want to follow up with the lab that we did on motion and kind of walk you through the math, review what we did, and then take it a step further. So we'll change the numbers a little bit, set up a different scenario. Instead of a marble rolling down a ramp, we are going to have a boy slide down a 6-meter ramp. Okay, it's a different situation, but physics-wise, it is the same. And let's say he does this in a time of 3 seconds. Okay, so he traveled a distance of 6 meters in 3 seconds. And so the first step on our way to finding acceleration would be to find the average velocity, which is our total distance over our total time. So we've got 6 meters over 3 seconds. So our average velocity is 2 meters per second. Just want to keep the math simple. All right, now to find acceleration. Acceleration is our change in velocity over time. Well, we know we started at 0, but we don't know what we ended at yet. So we have to find our final velocity. So we know that our initial velocity is 0. We know that we need final velocity, that's our question mark, and we know our average velocity was 2 meters per second. We also know that the average is just the sum divided by the number, so our average velocity would be the same as our initial velocity plus our final velocity divided by 2. Now, our average was 2 meters per second. That equals 0. 0 is real easy to add and subtract from. Okay, so 0 meters per second plus our final divided by 2. In these situations, I like to make fractions on both sides and cross multiply. So I've got 4 meters per second equals 1 times 0 plus our final velocity. So it would just be our final velocity. And as a general rule, if you start at rest and acceleration is uniform, your final velocity is double the average velocity. Now let's find acceleration. Acceleration is how fast your velocity change, or the rate of change of your velocity. So we say it's delta V over t, change in velocity over time. So our acceleration would be, if we started at 0 and we ended at 4, our change in velocity would be 4 meters per second over 3 seconds. And that would give us 4 divided by 3, it'd be 1.33 or 1 1/3, however you want to write that. And it would be a meter over a second, or I write meter per second squared. If you write it meter per second, that is also fine. Now, there are other formulas. These are pretty basic ones. Velocity is distance over time. Acceleration is change in velocity over time. These are pretty basic formulas. There are other formulas, or what are called derived formulas. So let's take the same scenario. We're going to travel down the ramp a distance of 6 meters, and we're going to do that in a time of 3 seconds. And we ultimately want to find our acceleration. So if you look at your formula sheet, there is an equation that kind of actually combines those other 2 equations, and it is d equals 1/2 at squared. Okay, so what we're going to do is we're going to come over here, and we're going to see if we solve for a using this, if we get the same answer or not. Okay, if we get the same answer, then this equation really is just derived from those other 2. So below the d, our distance was 6 meters. And I'm going to put the a in parentheses because that's what we're solving for. We're going to leave it as a letter. Our t was 3 seconds, but we have to square that. Now I'm not going to skip any steps, so I'm going to write 6 meters again. I'm going to do 1/2 a, not a very good a. 3 squared is 9. but you also, the unit also becomes squared, so you'd have your seconds squared there. Now I'm going to clean up that side. I'm going to say 6 meters. 1/2 times A times 9. Well, 1/2 times 9 is 4.5. And we have to keep the unit there, second squared times A. To solve, you just divide by whatever's in front of the letter. So we're going to divide both sides by 4.5 seconds squared. That crosses that out. So my acceleration would equal 6 divided by 4.5 is 1 1/3 or 1.33. And I got a meter per second squared. So it matches up. So we're good.